Rocks and minerals are fundamental to understanding Earth's structure and the materials that make up our planet. At the core of geology, these natural substances help us explore the history, makeup, and even the future of Earth itself. Whether you're standing on a solid rock surface or holding a shiny gemstone, rocks and minerals are the building blocks of the world around us. A mineral is a naturally occurring, inorganic solid with a defined chemical composition and a crystalline structure. These elements combine to form the various types of minerals found on Earth. Minerals are incredibly diverse, but they all share a few basic characteristics. They must be naturally occurring, meaning they're formed by geological processes without human intervention. They also must be inorganic, not made from living organisms. Each mineral has a unique chemical composition, like quartz, CO2, and a specific crystal structure, which is how their atoms arrange themselves in a repeating pattern. This crystalline structure is what gives minerals their recognizable form, whether it's a smooth, glassy surface or sharp, jagged edges. Some minerals, like diamonds, are prized for their beauty and rarity, while others, like feldspar, make up a significant portion of the Earth's crust. Rocks, on the other hand, are naturally occurring solid masses made up of one or more minerals. Unlike minerals, rocks can also contain organic material, such as fossils. The three main types of rocks, igneous, sedimentary, and metamorphic, are classified based on how they form. Igneous rocks form from the cooling and solidification of molten rock, either from magma beneath the Earth's surface or from lava erupted during a volcanic eruption. When magma cools slowly beneath the Earth's surface, it forms intrusive igneous rocks like granite, which are coarse-grained and contain large crystals. On the other hand, extrusive igneous rocks like basalt form when lava cools quickly on the Earth's surface, producing fine-grained textures. These rocks are found in oceanic crust and areas with active volcanism. Sedimentary rocks form from the accumulation and compression of sediment over time. Sediments are particles of rock, mineral fragments, and organic matter that accumulate in layers. As these layers build up, pressure causes them to cement together, eventually forming solid rock. Sandstone, for example, is a clastic sedimentary rock made from sand-sized grains, while limestone forms from the accumulation of calcium carbonate from shells, corals, and marine organisms. Coal, another type of sedimentary rock, is composed of plant material that has undergone a process of compression and heat over millions of years. Metamorphic rocks are formed when existing rocks, either igneous, sedimentary, or other metamorphic rocks, are subjected to high heat and pressure deep within the Earth. This intense environment causes the minerals within the rock to recrystallize and change in texture or structure. Marble, for example, forms when limestone is exposed to heat and pressure. The transformation of a rock can also change its appearance. Slate, for example, is a metamorphic rock that forms from shale and exhibits a fine-grained, foliated texture. To understand rocks and minerals better, it's important to learn about the various properties that help identify them. These properties include hardness, luster, color, streak, and cleavage. The Mohs scale of hardness helps to determine how resistant a mineral is to scratching, with diamond being the hardest known mineral. The luster of a mineral refers to how it reflects light, which can be metallic, glassy, or pearly. Color can be a helpful indicator, but it's often unreliable since many minerals can come in different hues. The streak of a mineral is the color of the powder it leaves when scratched on a porcelain plate, and cleavage describes how a mineral breaks along flat planes. This is why some minerals, like mica, break into thin sheets, while others, like quartz, break with a more jagged fracture. Understanding the rock cycle is also key to appreciating the dynamic and ever-changing nature of our planet. The rock cycle shows how rocks can be transformed from one type to another. Igneous rocks can break down into sediment that eventually forms sedimentary rocks, which can be subjected to heat and pressure to form metamorphic rocks. Over time, metamorphic rocks can even melt to form magma, which cools to create new igneous rocks. This continuous cycle of transformation is driven by processes such as erosion, melting, and plate tectonics, which constantly reshape the Earth's surface. In the world of common rocks, there are some that stand out due to their wide use or geological significance. Granite is a coarse-grained igneous rock that is commonly used in construction for countertops and buildings due to its strength and durability. Basalt, another igneous rock, is often found in volcanic regions and is the most common type of rock in the Earth's oceanic crust. Limestone, a sedimentary rock, is often used as a building material and forms the foundation of many fossils, making it an important rock for understanding past environments. Sandstone, with its varying colors and textures, is another common sedimentary rock used in construction and landscaping. Slate is a fine-grained metamorphic rock that's valued for its ability to split into thin sheets, making it useful for roofing and flooring. Meanwhile, marble is a metamorphic rock that is prized for its use in sculpture and architecture. Minerals, too, have their own significance. Quartz is one of the most abundant minerals on Earth, known for its hardness and versatility. It is used in everything from electronics to jewelry. Feldspar makes up about 60% of Earth's crust and is commonly used in ceramics and glass production. Calcite is found in limestone and marble and is essential in the cement industry. Mica is a silicate mineral that's valued for its insulating properties, often used in electronics. Gypsum, a soft mineral, is commonly used in drywall and plaster production. Hematite, an iron oxide, is an important source of iron ore, used to make steel. Rocks and minerals play a crucial role in our daily lives. Construction relies heavily on various types of rocks for building foundations, roads, and structures. Minerals like diamonds and gold are not only valuable but are also used in industry for electronics and cutting tools. The study of fossils, which are often found in sedimentary rocks, helps us understand Earth's past environments and evolutionary history. Minerals and rocks also provide essential resources such as coal, oil, and natural gas, which are critical energy sources. Studying rocks and minerals not only helps us understand the Earth but also provides insight into our past and future. The geological processes that form and transform rocks are ongoing, and by learning about them, we can better understand natural phenomena like earthquakes, volcanoes, and weathering. By studying the composition of rocks and minerals, scientists can also predict changes in the environment, helping us manage resources and environmental risks. In conclusion, rocks and minerals are much more than just objects we find beneath our feet. They are essential to the functioning of Earth and to our everyday lives. From the deepest depths of the Earth's crust to the gems in our jewelry, these substances shape the planet and provide us with the materials necessary for building, energy, and technology. Understanding them is crucial not just for geologists, but for anyone interested in the world around us and the natural forces that shape